Hello there! In this showcase, I'll take you through the technical backbone of this project, the systems, blueprints, and design choices that shape how everything comes together on screen. The game is structured around two primary blueprint classes. The first is the level manager, which controls the overall game state, flow, and progression. The second is the coin blueprint, which represents the core interactive element of the gameplay. The coin blueprint is instantiated 3 times, and each instance is assigned an index, so the system can differentiate between them and track their state individually. This indexing allows the game to manage transitions, detect outcomes, and evaluate interactions between the coins. Throughout development, I iterated between different functional approaches, testing logic branches, switching execution paths, and refining how the level manager and coin blueprints communicate. These experiments informed the final interaction model, and the functions I will present later illustrate how the system evolved into a stable and modular structure. Now I'll go through the coin blueprint. The coin blueprint is relatively simple in structure. It consists of a static mesh that represents the coin itself, and an additional hand mesh attached to it. The hand allows for animated interaction, and it is shown or hidden dynamically through code, depending on the state of the coin. On event begin play, the blueprint executes a sequence that initializes its visual variation. At this stage, the system generates a random float within a full 0 to 359-degree range. This value is applied to the coin's z-axis rotation, producing a subtle tilt and preventing the coins from appearing fixed or identical. Because of this randomized rotation, each time the game starts, the coins display different surface orientations, sometimes showing the face, sometimes the back, and sometimes angled between them. This adds visual realism and prevents repetitive placement. Additionally, the coin supports zoom interaction controlled by the mouse wheel. The wheel input drives an alpha value that adjusts the zoom level, and this behavior is managed externally through the level manager blueprint, which controls when zooming is enabled and how it affects the presentation of the coin. The zoom behavior of the coin is driven by an alpha value that updates continuously on tick. This allows for smooth interpolation while the mouse wheel adjusts the zoom level and ensures that the transition remains responsive and fluid throughout interaction. The coin also includes a rotating hand element, which continuously orbits around the coin mesh. This rotation makes aiming more challenging and introduces variability into the angle of the shot. The rotation is controlled through a timeline, which defines the speed and motion curve of the hand as it moves around the coin. Pressing the tab key switches control between the 3 coin instances. When this happens, the hand on the current coin is disabled. The next indexed coin is activated, and the rotation timeline reinitializes, allowing the player to regain visual reference and prepare the next shot. Another key interaction is the spacebar, which determines the force applied to the coin. When space is pressed, the rotation is halted, and a separate timeline is used to define the strength value. Once released, the system takes the final energy value from that timeline and applies it as an impulse in the forward direction of the coin, launching it according to the selected power level. Once the coin is launched, control shifts to the level manager. At this point, the coin blueprint has completed its role for that stage, and the level manager becomes responsible for evaluating the outcome of the shot. It monitors the state of all 3 indexed coins, determines the result of the interaction, and manages the progression logic that follows. In the next section, I'll go through how the level manager handles these post-launch events, how it interprets the game state, and how it coordinates the next steps in the gameplay sequence. On begin play, the level manager retrieves the player controller and runs an initialization sequence. The first step is to gather all actors of the coin blueprint class, which results in the 3 coin instances used throughout the game. The manager then sets the camera to focus on the starting coin and enables the hand mesh for visual interaction. Based on the currently selected coin, the level manager also configures the mouse wheel input, which ties into the zoom functionality handled through tick. At this stage, the system is in its starting configuration. Similar to the break position in a pool game, everything is in place, and the only remaining task is determining the strength of the initial shot. After the opening state, the player can choose which coin to advance with by pressing the tab key. When tab is pressed, a sequence of logic executes. The manager first confirms that the current coin is not moving, then sets the secondary overlap flag to false and hides the hand mesh to allow switching without interference. The system then increments the coin index, and when the index reaches 3, it resets back to 0. This index determines which coin becomes the active coin. Once the new coin is selected, the hand mesh is made visible again. The next steps in the sequence include recalculating the line trace between the remaining 2 coins, switching the camera to the newly selected coin, and ensuring that input control is now assigned to that coin. All of this occurs from a single press of the tab key. And this does not yet include the logic that runs when the tab key is released. On releasing tab, the system evaluates whether progress has been made and determines the next state in the gameplay sequence. Pressing the spacebar determines the strength of the coin flick. The power value is generated through a timeline that the player charges before release, and this value is then used to calculate the impulse applied to the coin, to prevent the player from repeatedly spamming the spacebar and continuing the trajectory artificially. The system includes a reset and cooldown phase. During this cooldown, input related to shooting is temporarily disabled, ensuring that the coin completes its movement before another action can occur. At the same time, the hand mesh is hidden to signal that the player no longer has immediate control and to avoid visual conflict while the coin is in motion. Once the cooldown concludes and the movement state is resolved, control can be reassigned and the hand mesh becomes visible again, allowing the next interaction to begin. During the cooldown phase, which is intentionally brief, a two-stage calculation begins to determine progression. The first stage uses a box trace positioned between the two remaining coins. This trace updates dynamically based on their locations. The goal at this point is to guide the flicked coin through the gap between them, similar to scoring between markers, and advance toward the end of the table. As the coin moves, entering the box trace, exiting it, or missing it entirely, each register different scoring states. These inside and outside conditions allow the level manager to evaluate whether the player successfully passed through the gate or failed to align the shot. Once the coin comes to rest, the level manager finalizes the score based on the recorded state of this first trace interaction. The second stage involves an additional box trace positioned on the far side of the current coin. This trace is recalculated every physics tick to ensure accuracy as the coins shift during play. Its purpose is to confirm whether the coin has fully passed beyond the first gate without failing the attempt. This secondary trace handles edge cases where the coin successfully passes between the other two coins, but stops exactly at the threshold, leaving to narrow a gap to continue to the next shot. In these situations, the system increments the inside count and registers progression, preventing the player from becoming stuck due to micro-precision positioning. To conclude the system overview, I demonstrate how the line trace logic operates, including the box traces used for progression detection. Visualizing these traces makes it clear how the game evaluates shot outcomes and determines whether the player has successfully advanced between the coins or failed the attempt. From this scoring logic, the UI layer presents either a win or lose screen. Both results are driven directly by the progression value calculated by the level manager, ensuring that the user feedback is tightly connected to gameplay evaluation. The game also includes a pause menu, accessible at any time by pressing the P key. This allows the player to interrupt play, review options, and return without disrupting the current state. In addition to the gameplay environment, there is a standalone main menu level. This menu includes UI elements that provide instructions on how to play, and it serves as the entry point into the level progression system. Once Level 1 is completed, Level 2 becomes available. The game stores this progression using a memory slot, saving the player's advancement and unlocking the next level accordingly. This ensures persistence across sessions and establishes a structured progression path through the experience. In addition to the gameplay logic, I also created the visual assets used in the project. The hand and the coin models were custom-made, and the hand includes an armature for animation control. Using a control rig setup, I was able to drive the hand animation directly inside Unreal, allowing it to respond to gameplay states and synchronize with the rotation and interaction logic. The main menu includes a cinematic sequence created in Sequencer, providing a styled introduction to the game before play begins. This sequence establishes tone and presentation and transitions smoothly into the interactive portion of the experience. For the win screen, I implemented a Niagara effect that reinforces the success state visually. This effect triggers only when the progression score reaches the win condition, tying feedback directly to gameplay outcomes and adding an additional layer of polish to the presentation. Bringing this project together required combining blueprint logic, custom assets, control rig animation, sequencer, Niagara, UI flow, and level progression into a single working experience. It represents both my technical growth and my ability to take an idea from prototype to a complete, polished result inside Unreal Engine. I hope you enjoyed the showcase.